Hello. Let's probably start with a round of introductions, maybe starting with Pavel.
Hi, I'm Pavel. I joined the Ethereum ecosystem as a dev a long time ago in the late 2014, and I actually was introduced in the heavy part because I didn't know anything about blockchain, and my job was to create a project called EVMJIT, which translated EVM to native code, and that was the beginning, and I kind of stayed with the EVM for longer.
Hi, my name is Andre. GitHub handle is Gumbo. I work with Ypsilon team for the past 4 years about that, and last 2 years mostly focusing on EVM Object Format, speccing it out, implementing and testing it.
My name's Daniel Farron. I am with the Hyperledger Basic client. Currently I work with Hedera. I was at Consensus before then. Mostly I focus on the EVM portion of the Basic client, working on performance mostly. I've been a Java developer since too long ago, which is why I'm very interested in the future of VMs, because I've seen systems do it very well.
And I'm Greg Colvin. I'm working for Hypercycle now. We might put an EVM down deep in there if it's going to work for us, but mostly I'm independent, and mostly I hang out here and be a pain in the ass.
Okay, amazing. Before we get into the panel, we have some slides to showcase.
Yeah, so one of the things we noticed looking at the schedule is there wasn't a talk focused exclusively on EOF. So I took a few of my slides from my Peep and Eep that I did with Pooja a few weeks ago to give people an understanding of what EOF really is. So you've heard this before, it's a container format. It separates the code and the data, which is something the EVM currently does not do. It also has code validation, which because we don't separate code and data, we cannot do as well. So by putting in this container format, we can do two important things. And the structure also allows us then to do things in the future, adding opcodes with immediates. And it also prohibits problematic behaviors like calling self-destruct. Those are some of the things we're getting from EOF. So let's tell a story of why we even need EOF. And apart from code, the immediates is kind of a more subtler story that kind of needs a pictorial example. It's really subtle. So let's just try and do it today with the EVF, create the E0 RJump instruction. And let's just, jump forward and backward. You can see the bytecode on the right. It's actually slightly slower than some implementations. And it'll work great if we could just put it in today. We absolutely would have done it. But here's what it looks like in implementation code. And here's what it looks like before we implement the E0 instruction. You can see there's 4 lanes. The top lane represents the stream of bytecode. The second lane represents the recognized opcodes that the EVM recognizes. One of the things that there is a rule in the EVM is you cannot have opcodes inside of immediate data for push operations. So this 5B jump code, which is the jump dest operation, is now hidden, is hidden in the second push 2 operation. You can't jump there. If you do a jump operation and try and jump there, the EVM will fault. And then we have in our fourth line at the bottom listed invalid code that's not recognized. So you could jump and it would fall for different reasons, or the E0 could become another valid opcode. Actually, the 5B in the second line is a valid target, and the E0 is invalid. But when we turn on a fork that would add this without EOF, all of a sudden, 5B becomes an invalid target. By implementing an immediate opcode, we have just changed the meaning of contracts that have been deployed for years. And that's because we can't validate code, we can't separate code from data. If you pay attention to Solidity, that EF separator is saying, okay, we're going into our data segment. So it's not even code that a well-formed compiler is even interpreting. But there are trolls out there who will write code that will cause problems and deploy that just knowing that we have it. I mean, we tried to reserve EF as a prefix, and they deployed EF emoji in a couple places just to be annoying. So we should rely on people causing problems in the EVM. And this allows us to do evolution that is more compatible. All the stuff on the left column are things that we can now add with EOF. Now, if we were to do anything on the right, we would need to have a new version of EOF, which EOF supports. but the idea for doing mega EOF is to make sure that we don't have to do anything on the right for 10 to 20 years, or never on layer 1 ideally. So that's why the list is so big, is because we literally want to do everything to avoid doing stuff on the right side of the list. So what does it look like in implementation? Well, actually, let's talk a bit about the EVM. Yes, the EVM will have to exist at the same time as the legacy EVM. They're going to have to operate in parallel. But you know what? They work great together. They call each other. They look the same. Unless you were implementing an EVM, you really wouldn't know when you're calling EOF and not calling EOF. And inside of it, they share almost all of the same code. The opcodes are the same for the most part. Storage works exactly the same. Accounts are the same. Message frames and reverts are exactly the same. Transient memory and memory work just the same. So here's kind of a picture of what it looks like today. Today we have some jump test analysis that you use to go through your code. And then this big loop in the middle is where we handle all the opcode and messages. And there's a collection of operations on the right that all the VMs have their different ways of getting into. So when we do a normal fork, we add 2 new operations. We just add two new little things. The main loop for the message frame stays the same. The jump test analysis changes the same. So really what we're adding with EOF is just an alternate container validator. Rather than the jump test analysis, which is now in blue, we have the yellow EOF container validation. We keep the execution loop the same because everything's working the same. And we're going to have some opcodes that only make sense in EOF and some that are banned in EOF and only available outside of it. But the core mechanics of the EVM remain the same. The core places, the core touches are all going to operate exactly like they were before. So here's a quick summary of the various things that we would want to change in what we call mega EOF. We could split this up into multiple releases, but that might impose some code debt on clients that we don't really want to expose the clients to. But maybe we need to do that, impose the long-term code debt so we don't impose as much security risks as to get to it. Those are details that I'd like to solve over the next few months. But the container itself, static jumps, subroutines, code separation, code introspection. I don't have enough time to talk about that. Gas observability. Stack validation is going to be essential for ZK translations. And also another stealth one, address space expansions. Nobody's talked about that. But that's coming up as something that people want to do. So those are basically, in 5 minutes, what EOF is all about. Yeah, we're getting rid of self-destruct. We're changing creates. And here's a list of all the opcodes we would change. Almost every opcode is just replaced by a different one. So yeah. So that's a quick summary of what EOF would be. And that's probably going to be some of the questions that we're going to get during the discussion.
Yeah, that was a great summary. Thank you for that. So let's get straight to the questions now. Speaking of EOF, there are some people who think that EOF doesn't need any changes to the EVM because it's just a standard on how the code is arranged. Do you agree?
The audio feedback.
Oh, sorry about that. So there are some people who say that EOF is just a standard on how the code should be arranged, and there shouldn't be any changes to the EVM because of that. Do you agree?
I disagree. I think it's too early to ossify the EVM. There are a lot of things in there that are difficult for things like ZK EVM. If I could choose how we would ossify the EVM, I would deploy EOF. I would ban deployment of legacy EVM code, and we would deal with what we have left because we could seal it and say we're never going to have anything more in the clients. And going forward, the only thing that could be deployed would be EOF code. And that would make things a lot easier for ZK proving the systems in the future, because some of the changes to the EVM code make it a lot easier to compile it to ZK circuits, make it a lot easier to compile it into native code. Greg can speak a lot about this. With some of these requirements, you can do linear compilation into native code without compiler bombs that you need to worry about, and other systems that do compilations. So I think we should ossify the EVM, but I think we should ossify it at a point where we know it is long-term, potentially forever stable. And I don't think we're there today.
Greg, what do you think?
Yeah, for me, the future is the past. I think I showed up here in 2015, and I'd spent years at Oracle before working on our JVM, not the one they bought from Sun. That's a pile of trash. We had built a JVM that still does run inside the Oracle kernel. and I was responsible for the interpreter. And one of the optimizations I'd done was simply to translate the stack code to register code. You just walk the byte code, and rather than moving things around on the stack, you just leave them in memory. And with a stack code, typically you take the top 2 or 3 things on the stack and you do an operation, and then there's one thing left on the stack, which is a result. And you're constantly duping and swapping and moving things in and out of memory so that you can operate on, on the things that are on the top of the stack. But real computers don't operate that way. They have instructions that operate on registers, operate memory to memory. So there's lots of inefficiencies. Even for an interpreter, you can get rid of those. You can get rid of most of the dupes, most of the swaps, most of the memory motion if you translate it. And it took about a day, and I did that, and I got to the first dynamic jump and said, oh, this can go anywhere, and every time around the loop, the stack can be a different depth. And so I would have to generate different code every time I went around the loop, and the code could just keep getting bigger and bigger. And I showed it to Christian. He's like, oh yeah, you can't do that. At which point I said, well, this is wrong. The JVM doesn't have a dynamic jump. WASM doesn't have a dynamic jump. C doesn't have a dynamic jump. Pascal doesn't have a dynamic jump. Fortran has a computed go-to. They got rid of that. In real chips, the Burrows didn't have a dynamic, well then, what do you have besides a dynamic jump? You actually have a function call operator. The Burroughs machine had one, the ones I've programmed. I didn't program the Cray, but I programmed the CDC, which was Cray's machine before the CDC, amazing machine. The PDP-11, the VAX, IBM 360, 8086, ARMS, I could list more, but pretty much every computer you'll program and every programming language you'll be in as a subroutine operator to work with. And not having it is a problem. I mean, just now I was talking to a couple people who do formal analysis for validating and auditing programs. And the guy says, oh yeah, I actually have to use complicated heuristics to even tell whether I'm in a loop or a function call. And for a certain number of programs, I can't tell. And the other guy said, oh, it's worse than that because you can actually stick a variable value into storage in one contract and pull it out of storage in another contract. And you can't tell what that value is unless you trace it from Genesis. And then the guy said, oh, and there's some other ones. Does it go quadratic or exponential? And he said, oh, actually, it's undecidable. So with the current EVM, there's a whole class of contracts that the formal analysts can't analyze. So there's all of these problems because it is so primitive compared to pretty much every other machine. And so I've been a pain in the ass because since 2016, I've been writing proposals for, what was it, 615, 2315, to get rid of dynamic jumps and have functions. And I think at this point with the EOF team, with some members of the Solidity team involved, we have enough brain power behind it to have gotten to a point of this is a complete proposal that does the job really well. And yeah, this is where we want to ossify. And I've gone on a bit, but another thing is currently you cannot translate EVM code to machine code or any kind of register code that you can interpret more quickly in linear time. Linear time matters because if you can't do it in linear time, it's a denial of service vector. And your compilers won't generate bad code like that, but your attackers will. So the current EVM just creates all of these obstacles to be able to both write high performance interpreters, high performance compilers, validators that can say this code, is safe in various ways, validators that can say we won't even put code that blows stack on the chain. You can't even put certain bad code on the chain. And hopefully we could have fast enough interpreters, compilers, that we can stop arguing about recompiles. It's just like, it's fast enough now. You don't need a precompile for every new elliptic curve that someone has invented. So this is why, for me, the future's the past, and I want to see EOF go in before I retire. I'm 69 years old. I can't keep this up much longer.
Andre, do you have anything to add?
Well, this concern that you mentioned that EOF is just a standard for the structure of the code, to me it sounds like some kind of a misunderstanding from the people who voiced this concern, because it's so much better, maybe so much more than that. Like maybe we were not very good at explaining it. Yeah, the main property maybe is extensibility, which is like not really achievable with the current legacy EVM. And like it opens the path to so much more. And there's this pre-deployment validation, which allows to not deploy bad code on chain, which Greg mentioned now. And yeah, and many like more properties that are useful for compilers, for ZKVM implementers, for static analysis tools, etc. And it's not really achievable if we would only, I think, if we would only deal with it like a standard for the code structure.
Amazing. Pavel, anything else?
Unsurprisingly, I don't have any kind of opposite opinion about that. I think the closest I'm here to Danos, if I understand it correctly, vision that we should get a chance to actually have EOF. And what I like about this for the future and like any other chains is that EOF will be kind of the equivalent target for compilers comparing to legacy EVM. And then I think you can define the EVM equivalence in the way that some chains only support EOF, so they can kind of get rid of legacy entirely. Maybe there will be some issues with that. Maybe like people have thought that that's risky, but I would really like to see at least trying to do this.
Okay, great. So sticking to the EOF again, if you had to pick one feature, what is the most important feature that EOF enables for VMs and compilers?
Okay, I guess me now. So I think just code validation. It's so much better than what we have. So how it works, how we just specify that is that the code you want to deploy to the chain will be validated, but it happens only in case of you send a create transaction. So it happens exactly once for every bytecode that will end up on the blockchain. So it's guaranteed, like whatever EOF code is in the state is valid, and it was in this blockchain terms validated only once. You have strong guarantees how the structure of the code is, and you can rely on this. So whenever you execute, all these checks we have to do right now are gone because we already validate that the code it's structured according to the rules we have. So we can forget about doing a lot of checks, and the execution of that it's way easier than the current EVM implementations.
Andrei?
Well, I agree with that. Validation is very important and like one of the most important features. But if I had to pick one feature or property, I would mention extensibility again. The EOF provides the path forward, the path to innovate, to change EVM in a safe manner without breaking the already deployed contracts. And we want to improve EVM, and just this is like, yeah, that's the best thing. Maybe this is not a feature for compilers as you formulated this, but like it's more general, maybe more high level property.
Dano?
So of the, I like the first two answers that were given, so I'll give a new one. And I think it's code and data separation. Some of the people on my team at Hedera are trying to look at contracts that are deployed. And if you're using Solidity, you get some very well-defined boundaries as to where the code starts and the code ends. But those are just conventions Solidity uses. And if you get some person who's going to hand code stuff or some troll that's going to build an attack approach, it's hard to figure out what's code and what's data, and it can be made to look the same. But without a standard way to separate those, it's hard to tell where your subroutine ends and your code signature starts. So, and you know, you can't just validate the code with code data because then there are certain sequences of bytes you can't use in your hash validation. So we got to have those two things separated, or we can't have code validation.
Greg?
Yeah, and ditto, ditto, ditto. But for me, I think I've said most important functions and no dynamic jumps. And yes, for formal validation, for ZK, when they hit those dynamic jumps, they have to go through heroics to deal with it. So all of these things have to happen, but subroutines and no dynamic jumps.
Yeah, great answers. So going back a bit to this ossification question, so I looked at rollup.codes. It's a website that shows you how each rollups are different and the different EVM parameters. Turns out Optimism, Arbitrum, Base, and few others still doesn't have push to row implemented. What makes these EIPs so difficult to implement? Greg?
I couldn't quite hear you. Somebody else should answer. Anyway.
So my question is, so if you look at some of the L2s, layer 2s, like Optimism, Arbitrum, Base, they still don't have push zero, which, and why do you think it's so hard to implement these?
You'd have to ask them. Push zero is way down my list of important things.
So this is a problem I've seen other alt chains that are not mainnet, is it takes a while for code to go down the pipeline. In this case, for the L2s, they use specific versions of Geth and specific modes of Geth. So before they can activate it in the next hard fork, it has to ship on mainnet. And then once it's on mainnet and activated in Geth, then they can integrate it into, it's not Bedrock, whatever their current Optimism fork is, or the Arbitrum fork, or whatever fork, whatever alt chain is doing. Once it's shipped, they can then plan for it. And the reason, being involved in this with Hedera, we don't make any plans to commit what we're going to ship until something goes on a testnet. Because as we've learned, days before we were about to put something on a testnet, subroutines got yanked. So, no, it wasn't even on, well, yeah. Anyway, it got yanked really late in the process. I mean, almost as late as when they changed EIP 2200, the net gas metering. These changes can happen really, really late. So it's not within the interests of anyone that's downstream in the greater EVM ecosystem, as long as L1 defines what is the EVM, to make plans to support new versions of the EVM until it's been activated on mainnet. So that's what's taken so long for push 0 to show up in layer 2s.
Andrei?
Yeah, I think they'll have it push 0 eventually. Yeah, it's obviously not an urgency for them. As far as I understood from governance panel, layer 2s want to implement what popular languages like civility target out of adoption reasons or marketing reasons. So I'm pretty sure they'll have. It's certainly not the complexity of push 0. What is it? Bottleneck?
Yeah, because I think that was part of the question which wasn't addressed. It's the push 0 instruction is trivial to implement, and even if it was more complex, I think that this is like absolutely not the core of the problem, right? So I think testing in all this testing and coordination around the changes are problematic. Actually, the implementation is probably the easiest part of all of this job.
Okay. So if they take so long for push 0, how long would it take for EOF to land on L2s and CKVMs? Do you think they would do it earlier than mainnet? Any answers?
I would assume it will take longer than push 0 than based on like historic experience, right? So yeah, definitely there will be the time gap that will happen. I'm not really expert like how it works following the Dano's introduction, how the dynamics are. So if it's to ship like a modified client implementation, the process will be the same. It won't be different from what is currently happening, because these changes will end up in all of the implementations, whatever the downstreams the implementation depend on will get the EOF if we decide to accept it on the mainnet.
So you don't really expect EOF to be starting at the L2s that, like some people want it to be? Dano?
I mean, this is a long-term play. I'm not going to deny that, to get EOF out there. Because, like you said, it's going to take, months after mainnet ships to get EOF. And in some ways, this is kind of a coordination problem, because I know, just the way that the EVM works right now, what is mainnet is what is the golden standard for EVM equivalence. And getting a different shelling point for people to agree on what is the EVM that does not consist of what mainnet does is going to take a lot of effort to get people to agree and take the chance. If Arbitrum and Optimism want to have, an EOF version before mainnet ships, they're going to have to agree on it. They're going to have to change the Geth, and they're probably going to have to fork Geth with a bigger diff than they already have. Because as we learned from the previous panel, Geth's not interested in implementing random opcodes from random chains because they'll wind up owning it. So unless they know that it's going to be a mainnet feature, I mean, I think it's a respectable position for them, and probably the right decision for them to keep their sanity, that we only support mainnet, we don't support your random operations. So that presents, a coordination problem on how we ship these. But again, even if it does get done on layer 1 before it hits layer 2, and layer 2 stays with the process of we're going to follow layer 1, in 2 years down the road, we're in a much better place to do more inventive things, like launch a chain that includes only EOF code. And that opens the door for many other opportunities, like you could have a regulated chain. We allow only these 5 contracts. And there are features within EOF that would allow supporting only those 5 contract variants to get supported and deployed within the chain without having to worry about deploying any random contract. I think this was an issue that the Palm NFT chain had when they started running with Besu, is if we give balance to any old person out there, they could deploy random contracts onto the chain, and they're trying to avoid that. So, and this is also useful for ZK systems. They could take the specific EVM contracts, compile them down into ZK circuits, highly optimized, and say we only support these 5 contracts. And so that's the sort of the future it opens up down the road. But I mean, it's not like, you know, we're going to see, you know, EOF on Optimism by the end of 24. I would be very impressed if that happened. But, you know, we're talking 25 before we're really going to see the larger ecosystem changes. But that's just where we are with a mature ecosystem. You can't just fire off and change things on a moment's notice like you could during the Shanghai attacks. You know, when you're $1 million chain, that's one thing. When you're $1 billion chain, you got to take things happen a bit slower.
Great answer. So maybe on going back to something that Greg touched on before, there is a lot of demand for adding new precompiles into EVM. Every other week there is a brand new elliptic curve proposal as an EIP. How can we find a sustainable solution so that all these people's needs are met without adding 100 other precompiles?
Well, we just had the EVMMAX talk, so that's one answer. That's a matter of some new opcodes that handle a large class of things. And I mentioned that if you're able to compile EVM code into a faster representation, like machine code, and if clients are able to switch a mode that says, for these contracts, we're not going to count gas. It's deterministic. We don't have to count gas. We don't have to check for Stack Overflow. These are deterministic contracts, but we don't have to write them ourselves in native code. We don't have to maintain all of this native code. We don't have to have, it was a bug in the mod. It was a bug in a Go library that had never been tested with an even modulus, because you would never use an even modulus in the real world, but if you're trying to attack the chain, it turned out to be a great way to do it.
Also found a generic big number.
Right. So if these were actually EVM contracts, those bugs would either be in the EVM contract and hopefully wouldn't be there. They'd be obvious, or the bugs would actually be in the client themselves. You wouldn't be digging through the Go code in the library trying to figure it out, doing all of that. Just anything you can do to increase the performance to the point that you don't need a precompile to meet your needs. And I think we could get to a point that you just wouldn't need precompiles. You could just tell people, fine, you could make it 20% faster, but it isn't worth the technical debt to make your contract 20% faster. I can go on and on.
That was a good answer. Pavel, what do you think?
Actually, I wanted to mention EVMMAX again, and this is I think the best solution I have in mind for that. I mean, the issues of precompiles are kind of like both. It also takes a long time to get it, so it's not like easy. It's easier than any change, and it's just like picks one of the application or like parts of the application that we kind of want to, I don't know how to call it, but some kind of enshrine or like subsidize. And EVMMAX, it doesn't help with all the precompiles we have. But if you see the precompiles that are proposed, like all of them are related to elliptic curves, except maybe one variation of the Blake hash again. So I think for what is proposed in the future, I think that helps a lot. Maybe there are cases where we really need to like get the native speed, but the good part is, like, first of all, EVMMAX is really simple to implement, much more simple than the complexity of the precompile. Secondly, when it's done, you don't have to ask us about the elliptic curve cryptography. You can just try to do it. You can do like competition, gas, golfing, whatever will implement it in the best possible way. and that will be public code, and we just need to put it in the blockchain, and that's mostly it. Maybe it will be 2 times like slower or like 2 times less efficient in the gas cost comparing to like super optimized precompile. But you just don't have to wait some years to get it.
Yeah, go for it.
So that reminds me of a proposal I saw in the Ethereum Magicians Forum that I think is a great plan going forward for those precompiles, and I think it was called progressive precompiles. So if you want to have your native curve, you write a contract for it and you deploy it at an address. And you do it and you make sure it works well. And eventually when enough people use it, the core devs can look and say, hey, that's the 256R1 curve and it's implemented in EVM code. That is going to be the address of the precompile. And what we're going to do in this next hard fork is we're going to change the gas schedule to make it cost half as much. And you're going to have to hard code that in. And all the chains that don't want to put in a native precompile, guess what? Just execute the EVM code. Yeah, it's going to be slow, but you'll still be compatible and get the right answer. And if you're concerned about speed, well then you don't have any problems, you know, writing native code, writing new code, and bringing in libraries to get it done correctly. And that also solves the specification problem, which is something that was had with the ModEXP precompile. How do you handle all the error cases? I saw another precompile back in the early days when I was a core dev that, you know, nailing down the error conditions. Well, it's in the EVM code. Your solution is, the specification is, here's the EVM bytecode, and here's a new gas schedule when you call it with these parameters. So that's, I think, the real future of precompiles, and that is that we're not going to get rid of precompiles. They're going to start out as EVM code, and if you don't want to spend the time playing with cryptography in your clients, then don't, because there's EVM code that does it for you correctly.
I would like to loop on this. Having EVM bytecode, and especially in EOF form, you can easily create a translator that will translate this EVM EOF container into whatever code your client is using. Like it can be Go, it can be Rust, it can be probably JavaScript as well. Maybe it won't be super efficient, but you also have like Go compiler that can increase the efficiency of that in the pipeline. And you most like take that, create like native code you would like. Yeah, it's generated, so it's not like maybe editable, but you include it in your client and you have like some number of speed improvement almost for free. We can just easily do these translators in open source. They are not very complicated, and yeah, you get that from this combination.
And this is the world where ossification is a happy place, because we have the definition frozen, and if you don't like running an EVM and your ZK compiler got quantum busted and you need a new ZK, you just recompile it in your new quantum resistant ZK system.
That's a very creative solution. I want to maybe take 1 or 2 questions from the audience. Anyone have any questions?
Nobody has any opinions about the future?
Come closer to the stage.
We have a mic for you.
That was not
Okay. So the question is, do you imagine like an EOF version where it's not deployed on mainnet but is used solely, for example, for a ZK EVM or something like that? Is that something that you could imagine happening?
It could certainly happen. So some of the definitions in the EOF header, there's a version number, and you could do your own version number. I mean, we probably want to, once we get this out the door, coordinate on how we would have a registry for those numbers. And there might be one like version FF and then 32 bytes, where your version number is the hash of your commitment. So you could have any arbitrary definition. But I see a world where you could have these EOF and say well, this is 2. And there's a simple translator that takes it back to version 1. And maybe the only difference is 2 is none of the precompiles are there, which would be really nice for ZK systems. So they can advertise in their bytecode that this is what's going on. And systems that are intelligent enough to recognize that there's 2 styles of EOF bytecode can easily translate one to the other. And in this scenario, it's like, great, well, let's just change the version byte to 1, because all that means is that well, these precompiles are back in play, but since nobody's calling them in anyway, it's safe to call in. So I think, you know, with the real header in the EOF bytecode, we can more easily communicate these constraints and requirements that we're putting on additional downstream code to make it more ZK friendly and to make commitments to say, hey, good news, we're not calling any precompiles.
Any other questions from the audience? There's a question over there.
There's one behind you, the guy in the yellow shirt.
Has there been any thought given to like doing something like typed bytecode in the EVM?
Could you repeat that?
Has there been any thought into like putting in typed bytecode into the EVM?
As in something smaller than 256-bit instructions?
Somewhat, yeah, but like.
So there's been thoughts of that. If you look at the Java spec, it gets really scary when you start putting typing in there because then your stack validation gets a lot more complex. They've had VM sandbox escapes that exploit this. You start, you know, getting risk of non-determinism. So there might be, but I don't think it'll land on mainnet just because, I mean, some of the core developers are skittish enough just about EOF in general. There would be armed revolt if we tried to get types in there just because of the security concerns. And I might be on their side for that, to be honest.
The other thing is if your code is dealing in these smaller quantities at your compiler level, you're going to be generating the mods and stuff to get rid of the bits you're not using. And then given EOF, if you're running some sort of compiler on the code, you can generate your own typed code. So like if you're generating Rust out of EVM code, your Rust code can be perfectly typed, even though the EVM code isn't.
Looks like there is one more question from there.
I'm just looking back to this earlier question of what if L2 is implemented first. I think my question is, what if L2 would implement EOF first? Would the L1 adopt it?
So I think also answering the previous question, I think it can happen that L2 will adopt EOF first, but I kind of, at the moment I find it less likely that the other way. So like the mainnet will be first anyway. So like if predicting something, I would like put it as something that will happen less likely than the other way. If that happened, I don't know. Like I would be afraid that like we in the mainnet are really picky about the stuff we actually accept, and I think the biggest risk if that happens is that the EOF that will be shipped to mainnet, if ever, maybe will not, will be a bit different or like some way different than the one that happened to L2. Because, I mean, maybe there will be technical reasons, but I think, well, if there will be technical reasons to do so, I think that they will likely overcome the ecosystem problems that arise from this. So that's my kind of take on it.
So if I could add two quick things on it. If that does happen, there's a versioning mechanism in the header. It would be easy to communicate that this is layer 2 EOF versus layer 1 EOF. So looking at the code, you could figure out what the differences are. But I think if layer 2 were to ship EOF first and make it work, I think layer 1 would be incentivized to take it as is. Because if it's deployed on a larger EOF that has a larger total value locked, people will have incentive to try and break it. And I think that would be evidence that it can handle the types of attacks that dedicated hackers would do to try and exploit the system to steal money if there's enough money to be stolen. So that is, I think, one of the strong arguments for why some of the other core devs are saying, can we do this on layer 2 first? Because if you have to shut down a chain because of a spec problem, you know, Optimism's main chain or Arbitrum's main chain might be a not happy place to do it, but that it wouldn't shut down all of Ethereum, and it's easier to fix problems in layer 2. So I think that's the spot they're coming from when they say, can we do this on layer 2 first? Because the solutions to things that they don't know are going to happen are a lot easier on layer 2 than layer 1. So I think that's the place they're coming from, and I understand it, and I understand the risk. It's just a coordination problem to try and get that to happen, to get these layer 2s to accept a bigger diff on what they run for their systems.
We have 1 minute left, so maybe one final question before wrapping up. Are we done?
Hello, okay. It's a bit of a personal question, if you don't mind. It's something that I see you guys are up here on the stage. You're experts in the future of EVM, this thing that we're all working on. And I just want to know, like, could you sum up in like a snappy sentence, like why you do this? What is it?
I'm a builder.
Yeah, it's just a cool piece of technology for me. One of the greatest projects that I ever worked in my life.
A question went by on Twitter a little while back. Someone asked, like, who is the oldest person on crypto Twitter? I won the contest, and she said, the reason I'm asking is I'm wondering how long can people stand this abuse?
Pavel?
Yeah, I don't have much more to say. I just happy to. I kind of like at some point like ended up in this EVM world. I cannot leave, at least for now. So I'm happy here, and yeah, hopefully that adds some value to the stuff.
Yeah, so one last question to end the talk.
Wait, what about you?
Sorry? Oh,
What's the
I think
reason
it's fun. EVM is fun. But one last question to end the panel. When EOF?
Yeah, can't really tell, but I think something that was mentioned, and I share this opinion as well, that it's longer. It's rather like long-term approach to this. So yeah, I think the first step is to make sure that we aligned a bit, that we really want to push with this, and then I think we have quite amount of time to make it make it work and test it properly.
Any other numbers, Van?
Not from me.
It's like deciding when the ice breaks in the dam. You know, when's the next hard fork going to happen? I mean, this was supposed to be the Cancun party until we started making sure that the blob stuff worked before shipping it. And I'd rather it be late than ship blobs early and watch something break horribly. So it's like asking a project manager, when's the project going to be done? It's going to be done when it's done. I mean, I can tell you what the steps are and what the landmarks we need to pass are. But for me to say it's like, oh, yeah, it's totally ship in June of 24 is like ridiculous. It's not, so.
Andre, do you have a number?
Either next year or maybe it happens on layers 2 first. That's my.
All right then. Looks like nobody has a conclusive answer to that. But thank you very much for doing the panel. It was a lot of new things. Yeah. Thanks for the audience too.
Okay.